In this circuit, we're being asked to compute this I naught using superposition. And if we take a quick look at it, you'll see that we have three different sources, two independent sources and one dependent source. So this dependent source will stay on all the time. So that means we only have one option if we're using superposition, which is turning off this one and keeping this one on. And then the other way around is like turning this off and then this one is on. And we'll compute it from there. And of course, this one, we're going to have to do some sort of analysis because this is the current through a voltage source, so I can't use Ohm's law. So let me get started. First, what I will do is I'll say, let's turn off this voltage source, or maybe, we can turn off, well, let's turn off this voltage source and then keep this one on and just see where do we go from there. So I'll just redraw that circuit in here. So that circuit tells me that we have 1 kilo ohms in here, and then 2 kilo ohm, and then connected to another 4 kilo ohms in here. That's 2 kilo ohms. That's a 4 kilo ohms. Okay, and then we're connected to this particular 40 volt source, and this source stays on because it's a dependent source, and it depends on another voltage that I'll write in a minute. And of course, we replace the 90 volt with a wire because this is how we this is why we turn it off. The voltage around it will become 0. That's 2 kilo ohms in here. Okay, so this one here is just simply 2.5 VB prime, because this one here now is my new VB prime, because remember, it's like the VB changes based on these sources, and the one that I'm looking for is this particular current, and I'm going to call it I prime. So now what we need to do is just focus on this particular circuit in here and just figure out what we need to do. What we really need to do is this particular current in here. So if you take a look at it, I have 1 mesh, 2 mesh, and 3 mesh. So I'll have to write 3 different mesh equations, and I'll have to incorporate somehow the VB prime and write it. So it'll end up with 3 different mesh equations. If I'm to write nodal analysis, I'll have one, it's actually, this is the same as all of the, this one is the same as this one here. So if we will have 1 essential node, 2 essential nodes, and 3 essential nodes. And frankly speaking, I will know this voltage in here if I put my reference. So that gives me this particular voltage node voltage. So I'll only need to write one nodal equation in here to figure out what the circuit is. So let me just go with nodal. I think it just, on the short run, it's just basically simpler. All right, so I will put, based on nodal, I'll put my reference node in here, and then I'm going to say, well, this here, you might be tempted to say it's 40 volts, but just remember, because we have that 2 kilo ohms in here, it is not 40 volt. It is 40 plus whatever the voltage in here is. Okay, so we're going to have to write a nodal equation in here. So in here, we don't need to write a nodal equation, and we don't need, well, this is basically, this is my reference. It's the same reference. It's the same node. Okay, so let's go from there. What I will do is I'll call this, for example, I'll call it maybe V1, okay? And we'll go from there. So let's write this equation. So that tells me that V1 minus 40 volts divided by 2 kilo ohms. This is basically the current going that way. You can rearrange it, like if you put the resistor before it, you will be able to see it. If you put the 2 kilo ohms in here instead of here, because they're in series, you will know that the voltage across it's just V1 minus 40 divided by 2. All right, let's take a look at the voltage in here. So the voltage in here is just simply, I believe it's V1 minus 2.5 VB prime divided by 4. And that's basically this voltage in here. And now the last one in here, which is that, which is equal, well, plus V1 minus 0 divided by 1 kilo ohm, which is basically 0. All right, so what we have in here is we have used that particular VB prime. So let me just see what VB prime is. So as it turns out, the VB prime is just simply negative V1. Take a look at this. So this is the negative in here, and this is the positive, but that's a 0 in here. So VB prime is exactly the opposite of V1. That's what it is, because V1 is plus minus. This one here is plus minus in here, and that's about it. All right, so all I have to do is just substitute it in here, and we'll figure out what the value of V1 is. So V1 minus 40 divided by 2 plus V1 minus 2.5 VB prime, which is actually plus V1 divided by 4 plus V1 divided by 1 equals 0. So let me compute that value for you. And that value will become V1 is just simply 8.42 volts. That's the value of V1. All right, so I think we have everything we need to figure out this I naught in here. Again, this is not Ohm's law, so we can't just use Ohm's law for it. So the only way I can think of it is In order for me to compute it, I'll compute what the current is in here. I'm going to call it, for example, maybe I1, and the current in here, I'm going to call it I2, and simply I prime will be just a summation of I1 and I2. So what is the value of I1? Well, simply it's V1 minus 2.5 VB, which is just simply negative V1, but let me just write it this way. 2.5 VB divided by 4, that will be the I1, okay? And we can compute that, that will be V1 plus 2.5 V1, because remember it's like V1 is just simply negative V1, or VB is negative V1, okay, divided by 4, that means this particular I is equal to 7.37, I believe everything is in kiloamps, so that should be milliamps. All right, what about I2? Well, I2 is simply, I believe it will be negative 2.5 VB divided by the 2 kilo ohms, which is just simply 2.5 V1 divided by 2 kilo ohms. So let me just give you the answer. And that will be 10.525 milliamps. So now we would know that I prime, the one that we're looking for, the effect of that 40 volts is just simply the summation of these two currents, which is 7.37 plus 10.525 milliamps, and that will be equal to about 17.895 milliamps. Okay, so we'll figure out the effect of that 40 volts and on that particular I prime or I. So now my second iteration now is, okay, so what we'll do is we'll turn this on, we'll keep this one on, and we'll turn this particular source off. So let me just draw that circuit for you. So here, zoom out a little bit. Okay, so let me just start drawing. So we will have the same resistor, which is 1 kilo ohms. Okay, we will have the same goes in here. That will be the 2 kilo ohms connected to another 4 kilo ohms, and then we do that here. So that will be 2 kilo ohms, and that will be 4 kilo ohms. And of course, the voltage sources, this stays on because this is now, this is what I'm studying, the 90 volts. This stays on because it's a dependent source. We don't usually deal with the dependent source, but now it's actually dependent on V prime prime, not VB prime and not VB. Okay, and this of course gets replaced with a wire because I'm just short circuiting it. So that will be 2 kilo ohms. And now what I'm looking for is the following. I'm looking for this particular current in here. This is I prime prime. And of course, I need to indicate that this here is plus minus VB prime prime. Okay, because this is what the voltage, dependent voltage source depends on. Okay, all right, so now what are we looking for? Well, quick analysis again, mesh, 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 like 3 equations for mesh. Or maybe what we can do is we can identify the nodal, and we can say, well, this here is an essential node. This one here is an essential node, and another essential node. I don't have to write an equation in here because I know it's a part of the voltage source in here. It's 2.5 VB prime prime, and I don't have to write any nodal equation, so I'll end up with one nodal equation here. So I'll do it with one nodal equation, and for example, I'm going to call this here to be V2. Okay, so let's just write that nodal. It will be V2, and frankly speaking, this V2 is just simply negative VB. It's not. Let me just do that. Because now this is not my reference, this is 90. Okay, so let me just write that nodal equation. So that will be V2 minus 2.5 VB prime prime divided by 4 kilo ohms plus, I believe it's V2 minus 90 volt divided by 1 kilo ohm. For some reason I decided to take this current and then this current. Okay, that's fine, it's the same. And then we do that in here, plus V2 divided by 2 equals 0. I believe I captured all the current. So V2 minus 2.5 V prime, that's good. Then V2 minus 90, that's good. And then V2 divided by 2. All right, so now the VB prime prime is not a nodal voltage, so I need to just rewrite it in terms of nodal voltages. And if you take a look at the circuit, you'll know that VB prime prime is just simply 90 minus V2. That's what I said. It's not exactly negative V2 because this now is 90 volts above the reference. All right, so all I have to do is just substitute that in here. Okay, and that will tell me V2 minus 2.5, and then this is 90 minus V2, okay, divided by 4 plus V2 minus 90 plus V2 divided by 2 equals 0, and that will give me the value of V2. And that value would be just simply about 61.579, for example, or 57 if you want it. Okay, all right, 7 or 58. Let's just do it. Let's just round it up. It's 0.58 volts. Okay, so we have that. So now we take a look at the circuit. We have everything we need. I'm going to do this something similar to what we did before. We're going to call this, for example, I1. We're going to call it well, let me call it I3 and I4 because I called the ones above, I believe, or down. It's like I1 and I2. All right, so what would be the value of I3? Well, the value of I3 is just simply V2 minus 2.5 VB divided by the 4 kilo ohms. But then I need to figure out what the value of VB is. Okay, well, I know VB is just simply 90 minus that VB or V2. So let me just write that in here. All right, so what's the value of VB because I'll be using it? So VB prime actually, this is VB prime is just simply 90 minus 61.58, and that will be equal to about 28.42 volts. Okay, so we just substitute these two values, the V2 and V1, and we'll figure out what the value of I3 is, and then we can compute what the value is, and that will be, after computation, is negative 2.367 or 37, for example. Okay, milliamp. All right, what about I4? So I4 will be simply 90 minus 2.5 VB prime divided by the 2 kilo ohms. So let me compute that, and that will be 9.47 milliamp. Of course, now we would know that simply I prime, the one I'm looking for, is just a summation of these I3 and I4. That will be 9.47 negative 2.37, and that will be equal to about 7.1 milliamp. Okay, so going back to the original circuit, so what we have, and I'll highlight this one here, we have figured out that I prime is just simply 7.1 milliamp. Okay, and what about I prime? Well, let's take a look. I believe I prime happened to be 17.895. So in order for me to figure out what I is, I just simply have to just say it's I prime plus I prime, and that will be equal to about 25 milliamp, more or less, with the approximation errors. Okay, so this is how we use superposition to compute any current in the circuit or any voltage in the circuit.